This one looks really hard. We have two different square root expressions in one equation. The problem is 2 times the square root of p minus the square root of p plus 5 equals 1. We will also choose from multiple choice answers. A2, B4, C negative 2/3, D4/9, or E none of the above. Before we solve it, I will show a common wrong attempt and why it gets messy. Then we will do a cleaner approach. A common first attempt is to square both sides immediately. Watch what happens. We square the left by the formula for a minus b squared. A squared minus 2ab plus b squared. We still have a radical term, negative 4 times the square root of p squared plus 5p. That means we would have to isolate this new radical and square again, making the algebra error-prone. A better way is to isolate one radical first, then square. Here is the better plan. First, isolate one of the radicals. Add the square root of p plus 5 to both sides, and subtract 1 from both sides. Now square both sides. Only one radical is present, so the result is simpler. Remember, 2 times the square root of p minus 1, quantity squared, expands as 4p minus 4 times the square root of p plus 1. Now isolate the remaining radical term, negative 4 times the square root of p. Then square both sides again to remove the last radical. Finally, bring all terms to one side to get a quadratic equation. We solve the quadratic by factoring using grouping. We look for numbers that multiply to 144 and add to negative 40, negative 4, and negative 36 work. Group and factor. Set each factor to 0 to get candidate solutions. Because we squared both sides, we must check for extraneous solutions in the original equation. First, check p equals 4. 2 times the square root of 4 minus the square root of 4 plus 5 equals 1. True. Now check p equals 4/9. 2 times the square root of 4/9 minus the square root of 4/9 plus 5 equals 1. That becomes 4/3 minus 7/3 equals 1, which is negative 1 equals 1. False. So p equals 4/9 is extraneous, and p equals 4 is the only valid solution. This was challenging because of two radical expressions. Avoid squaring both sides immediately. Instead, isolate one radical first, then square. That led to a clean quadratic. And after checking for extraneous solutions, the correct answer is p equals 4, which is choice B.